Yes, sir.
I have shared that with different device. Okay. So let's start with first question. What is the band of 7 colors? So what you guys answer?
The spectrum. Option B.
Spectrum. Okay. Other? Dhriti, you were saying something?
WebGL is also one.
Sir, can it also be WebGL?
Yeah, it is. So because spectrum is the whole band of not only colors but of whole light.
Correct.
And
Correct.
when we talk about colors, it's only WebGL. WebGL is
Yes.
more specific.
Sir, but
Sir,
in
I
my
know
textbook,
WebGL.
sir, but in my textbook, it's mentioned as spectrum for some reason.
Yeah, it is spectrum.
What it has mentioned that band of 7 colors is spectrum.
Yes, sir, it
Yes,
is.
sir.
I mean, in the textbook, it was mentioned as spectrum, sir.
Okay.
In the 7th grade textbook, it was mentioned as spectrum.
Hmm. Okay, if it is mentioned as spectrum, then go by that answer. Okay. So I wanted to frame this color as I wanted to ask you.
Sir, but I wrote, sir, but I kept WebGL, sir, because spectrum was in my 7th grade textbook. And right now we're at that spectrum is the whole types of colors. So I kept WebGL.
That is also correct. Like I when I again saw this question, I was also both answers are correct. Like Vibgyor can be answered and spectrum also can be answered because spectrum of colors, like band of colors, whether that color be 5 colors, 6 colors, 7 color, 8 color, or 9 color, that should be spectrum. Okay, but here I particularly wanted to ask that what is what does this band of 7 colors contain? Okay, but we can see that in question there is not mentioned any regarding that what those colors could be. Okay, can you see that it is asked as the band of 7 colors? So it haven't asked anything regarding particularly about a color, so we will go with
Sir,
spectrum.
what is the correct answer?
Spectrum. So I evaluated your questions, your copies according to Vibgyor. So those who have answered as spectrum, that is correct.
Yes, sir, it's spectrum. I searched in Google. That is spectrum.
So the answer for this is spectrum. Okay, if any question can contradict what is written in a book, so you can tell me directly. We will see to it. Okay, fine. So answer for first question is spectrum. And if I ask what is the band of
What
7 colors rainbow?
WebGL, sir.
Then what will you answer?
Sir,
WebGL.
WebGL.
Vibgyor. Yes. So in this case, we will write Vibgyor. Can anyone of you tell me what this particular word mean? Which color it does mean? What V stands for?
Violet,
Violet.
Violet, indigo, blue,
indigo,
green,
blue,
Violet,
green,
indigo, blue,
yellow,
green,
orange,
yellow,
red.
orange, red.
Blue,
Green,
green,
yellow, orange, red.
yellow, orange, red. Great. So Vibgyor is this. Now second question. Dash is not a source of light. So sun, is sun a source of light?
Yes, sir. The sun is the source of light. The firefly is the source of light, and tube light is the source of light. So the
Moon
moon
is
is
not.
not a
Answer
source
is
of light
moon.
as it's just the sun's reflection falling upon the moon.
Great. So how we are able to see moon? Because
But
it
because the sun,
reflects
yes, sir.
light.
Sir, but why does the moon not produce light?
like these sources differ by their characteristics. Okay, so do you know how sun produces light?
Through nuclear explosion, sir.
Okay,
Nuclear.
good. Let's see how sun produces light. Okay, sun. So sun. Uh, tell me one thing, that does sun have a surface?
No, sir.
No, sir.
No. Okay, why not?
Because it is not solid, sir.
It is not solid. Tell me about Jupiter.
So what is the question, sir?
It is a
Do-
gaseous planet.
So
sir,
what is the
Jupiter.
question?
Does sun have a surface?
Uh, yes, sir, it does have a surface. Because we talk about the surface, the temperature of the surface of sun.
Temperature of the sun. Okay.
Sun is having a surface, but
Hmm.
it is not a solid. The only solid part in sun is the core.
Yes. So only solid. The sun only has solid part,
Core.
which is core. Okay. The core is only solid part. Then what is other part of sun?
Gases, sir. Which is the
Gas.
mantle, I suppose. Sir,
Okay. Which
can you also
gas?
classify it as crust and mantle?
Hydrogen.
Hydrogen and helium.
It contain hydrogen and helium. Okay. So sun has a solid core, and apart from it, the whole part which we see as like if you see sun, you will see that it is a kind of solid planet. Okay, solid star, but it is not solid. Only core is solid, and apart from it, the outer part is all gas. So this outer part is all gases, and these gases are hydrogen and helium. So how sun produce light? Hydrogen and helium, these undergo nuclear, not hydrogen and
Reaction.
helium,
No, sir.
but
Helium is released as with the reaction of helium with another. No, helium is released when hydrogen is reacted with something other. Is it?
yes. So hydrogen undergoes nuclear fusion, not fission. There are two. One is nuclear fission, other is nuclear fusion. Okay.
Yeah.
So I will tell you, if you don't know, I will tell you these differences. So one is nuclear fusion, other is nuclear fission. So fusion means we are fusing two gases. Fusion, like we are combining two materials. Okay, so fusion means that we combine two material. That is, we are fusing. If you have seen cartoons like Dragon Ball Z or something like that, there are some characters which to increase their power. To increase their power, they fuse. Like if let's say there are two characters, one is Goku, other is Vegeta. So what these two characters do, the both has very much power. Okay, their energies. So what these two characters do, they fuse, they become one. So by becoming one, their power increases exponentially. Okay, so from this, like from this context, you can clearly I say, you can clearly observe that with fusion there is increase in energy. Okay, so both in fusion and fission. First, fusion means we are combining two, what I have written, combining two material, or rather we say gas. So when we are combining two gas, so when these gases combine, they release energy. So this energy is very high. Okay, so we are talking about nuclear fission. That means we are breaking a material. Example, uranium. And here example is
Sir, is it the breaking up of protons and neutrons?
not protons and neutron. This is different reaction. First, like if I say, do you know how this nuclear power plant work? So let's first take nuclear fission. So you don't have any confusion. I will write this again in a tabular form so that it will be clear. Okay, so first we are talking about nuclear fission. So what I have told, that what happens in nuclear fission, do that two materials combine or one material will break? What will happen?
One material will break, sir.
One material
So what
will
about
break.
the other? What about the other material?
What about other means?
I mean, will it to break or will it remain intact?
I'm coming to that part. Okay, so let's take example of nuclear reactor. Do you know we like in India we have nuclear reactors?
Yes, sir.
Yes, sir.
Yes, we have nuclear reactors. So what does this nuclear reactor do?
They provide electricity.
They provide electricity. So these nuclear reactors provide electricity. Yes.
Sir, the
What?
energy released when the material is breaking in nuclear fission, maybe that energy is converted into electricity.
Correct. Very correct. So we like in short we can say it produce
Energy.
energy. So how it produces energy? This nuclear reactor has uranium 235. This 235 is its atomic mass. So this nuclear reactor contains uranium. U stands for uranium. So there present large number of uraniums, and we react it with the help of a neutron. Then this uranium breaks into some element X and X. Okay. Then this is again reacted with neutron. These are again break. So due to this process, it produces energy. This produces energy, and this energy is so high that even it can destroy or it can burn a complete planet. Okay, so
It can,
So
there is
can one nuclear planet burn our
The
entire Earth?
nuclear reactors are found in labs, right?
it is a lab, like it is a kind of factory. You search for nuclear reactors. Okay, Google it and see what is a nuclear reactor and how it looks, and read about it, that how it works. Okay, so
So can
nuclear,
a nuclear plant destroy Earth?
we will come to it. Okay, first let's know all about nuclear fusion and fission. We are right now talking about nuclear fission. Okay, then we come to fusion, and then we will then I will answer your question. Okay, so I am telling that it produces energy. So with this energy, we what we do, how we produce electricity? We, like, there is water. Okay, and this water, when this energy, this is a kind of energy. So what one energy do? It will
become water
boil.
vapor.
It will become water vapor.
Water
Correct.
vapor.
Or we say it becomes steam.
Steam.
Yes.
Again,
so we are using this energy to make this water as a steam, and then this steam is used to rotate turbine.
The turbine, and then it will produce. It will convert the energy into electricity.
Yes,
So
these
is
road.
is it the heat energy which is being produced by the nuclear reactor in the first place?
Yes,
Okay.
it produced heat energy, but generally we say energy. Okay, so energy is whether it can be heat energy or other kind of energy. All kind of energy are non-destructive. Okay, so energy, you will later know that what this energy mean. Any kind of energy can turn this water into steam. But let's see how. Okay, uh, yes, we were to rotating turbine. So first water is there, then this energy, with the help of this energy we converted this water into water vapor, or we can say steam, and this steam then is used to rotate turbine. So do you know any other example where we rotate turbine to produce electricity?
Ma'am, sorry, sir, in water, like dams,
Dams.
dams.
Dams, correct. So in dams also, in
So
dams what we
windmill.
use, windmill also, very good,
Yes,
very good. So dams and windmills.
wind.
So we rotate those turbines, and with the mechanism of this turbine, electricity is produced. Okay, in dams we use water, and in windmills we use
Wind.
wind. Correct. So similarly, here also we are using nuclear reactor. How nuclear reactor works? There is uranium. Uranium is reacted with neutron, and with the help of this, energy is created. This energy is used to convert this water into steam, and this steam in turn will rotate turbine, and this rotating turbine will produce electricity. So this is how nuclear reactor works. And nuclear fission. Do you have any doubt in nuclear fission?
No, no, sir.
No. Good. So this is nuclear fission. Next, we are talking about nuclear fusion. So what I told about nuclear fusion. What is nuclear fusion?
Sir, combining two
Combining
particles.
of two materials.
Two. Okay. Do one correction, that instead of material we will say element. Okay.
Elements.
Instead of material we will say element. So do you know that hydrogen is also an element? Helium,
Helium,
lithium,
lithium,
beryllium, boron,
beryllium,
all.
boron, carbon,
This uranium is also
material.
a element. Say it as element. Okay. So these are all kind of elements. So in nuclear fission we use uranium, and nuclear fusion we use hydrogen. Okay. So
Sir,
in nuclear
uranium is dangerous to the environment, right?
uranium is
Dangerous. It is dangerous to the environment, right, sir?
we cannot say dangerous, but when it is reacted with some material like some other like proton, neutron, electron, or other element, when it reacts with other element, then it is dangerous. But alone uranium is not dangerous. Okay.
Okay, sir.
So any element, like you have seen that, do you know that H2O is made up of hydrogen,
And
H2,
oxygen.
and oxygen? So alone hydrogen and oxygen cannot form water, but it is until they combine, they become H2O. After becoming H2O, it water is created. Okay. So similar is case with uranium. Alone uranium is not dangerous, but when it combined with neutron, then it becomes dangerous. So nuclear fission, we combine two elements. So we take example of sun. So sun has hydrogen. This there present many hydrogen. The sun atmosphere has large number of hydrogen gas. Okay, when these two combine, helium is created, and in the process, they are created some energy. Okay, so this energy is responsible for sun to be a star. Like this energy is very high, that it is burning in star, and that energy is transferred from star to earth. That's why we are able to like we are daily daily have that sunlight, and with the help of sunlight all the life life cycle works. Okay, so due to this, due to nuclear fusion, sun produces energy which we see in the form of light. Okay, so
And heat, sir.
yes, we can say this energy is heat. Okay, and we are able to see this. So tell me, have we achieved anything regarding nuclear fusion on our planet, on Earth?
Yes, sir.
Yes, where?
Sir, sun, sir.
Sun. I'm asking about Earth. Do we have anything related to nuclear fusion on Earth?
Power plants.
Power plants. Okay, so those power plants, those work on nuclear fission. Is it clear? Those work on nuclear fission. I'm asking about fusion. Fusion. So there, one example of nuclear fusion is hydrogen bomb. So this hydrogen bomb works on principle of nuclear fusion. It contains hydrogen, which combine, and it creates so large destructive power that go, like after this class, go and see for Hiroshima
Nagasaki.
and Nagasaki. So these two cities are in Japan. So after this class, search for Hiroshima and Nagasaki and see
So
how
in
the
Earth's core, there will be nuclear fusion, right?
what
In Earth's core, nuclear fusion will work.
we don't know anything about Earth's growth. So let's talk about anything which we know, which is present in our daily life. Okay. So if anyone does not know about Hiroshima and Nagasaki, go and check for Hiroshima and Nagasaki and how these two cities were destroyed. So when one country, that is USA dropped a bomb which is hydrogen bomb on Hiroshima and Nagasaki, and this bomb completely wiped these two cities. Okay, so this bomb is so destructive that it killed all every species present on every person, building, anything. It destroyed everything on these two cities. So we have example of hydrogen bomb as nuclear fusion. So our scientists are working to develop nuclear fusion in labs also. Okay, so this hydrogen bomb is constrained. Like this will contain this hydrogen bomb will spread in small area, but not large. If this hydrogen bomb spread very much, that it can destroy Earth also. Okay, but this is a controlled hydrogen bomb. It is controlled reaction. So our scientists are doing some work to develop nuclear fusion. Scientists, they are trying to do nuclear fusion in labs. So how, what will they do if they create nuclear fusion? This nuclear fusion is produces so high energy that it can even power sun. Like sun is present there for billions and
Sir,
billions
but we
years.
need to, on Earth to generate the nuclear fusion, we have to have a 150 million degrees Celsius.
Yes. So you know that sun is so high, it
It
has
is
so high
about 7
temperature.
times hotter than the sun.
Yes, 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 yes. The sun has so high temperature that no other, like we send some satellites and some other observatory satellites to sun, but it cannot go near. Why? Because its temperature is so high that it can burn anything. So that's why this nuclear fusion is produces so high energy that it can even does not have any material. Okay, so nuclear fission produces energy, and we have material to contain that energy. Okay, so we can contain this energy, but nuclear fusion produces so high energy that we does not have any kind of material which can hold this energy. What will happen if we create nuclear fusion in labs? That this produces so
Then
high
very
temperature, it can
it will become an explosion.
explosion. Instead of explosion, we can say that its temperature is so high that it can melt everything.
Yes, sir.
So what conclusion arises? That nuclear sun. Wait, we were talking about sun now. So sun works on principle of nuclear fusion. Okay, right? And we use nuclear fission on Earth in nuclear reactors to produce energy or electricity. So we were talking that why sun is a is a source of energy, whereas moon is not a source of energy. So sun has a particular type of gases. These gases perform nuclear fusion, and with the phenomena of this nuclear fusion, it produces so high energy that these act as a source of light. Okay, whereas moon is almost all as a solid part. So moon is a solid part. Moon is all solid. Okay, so moon does not have those type of gases which can produce this high energy. So are we clear with this, that how sun produces energy and why moon cannot produce energy?
Yes, sir.
Oh, great. Others? Yes, Rohit. Have I answered your question?
Yes, sir.
Okay, fine. Others also, if this does not get bored for you, can you answer
Sir, it
that?
is very interesting, sir.
Oh, great. It is interesting for Ashwath. What about others?
It is good, sir.
Good. Right.
Sir, it is good.
Great. So ask me if you have any doubt. Like you must have heard this thing like first time. So you can ask me any doubt, like how, if anything, how works. So I will try to explain you a different way. Like this is a basic phenomena, how sun produces energy. Like if you know that I talked about how scientists are trying to produce a material, a kind of material which can hold the power of this nuclear fusion. Okay, nuclear fusion. So if they are able to create a specific type of material which contain energy of this nuclear fusion, then we won't have any kind of shortage of energy. Okay, like sun has so vast amount of energy, we will have that energy on earth also, and we will able to provide electricity and all kind of energy on every part of earth, right? So this nuclear fusion is so important, like it can produce so high energy. Okay. Nice.
Sir,
I-
if energy can be produced by nuclear fusion, it is inexhaustible and it is infinite, sir.
it is inexhaustible. Correct. Like you can see in sun. From
But sir,
sun,
for some stars, when there will be a point that they cannot produce that energy anymore, right, sir?
there is some point, but that is billion and billions of years. We
Sir,
won't
so
be able to.
if a nuclear fission plant or something is built on Earth, and if possibly it can hold that energy in a fixed place,
Mhm.
there are chances for that uh, container to break, right, sir?
So I told you that how nuclear fusion works. We add two hydrogen, right? We add two
Yes, sir.
hydrogen plus hydrogen. So do we have like deficiency of hydrogen? We have hydrogen present in our atmosphere. So if this nuclear fusion energy exhaust, we will produce more energy. We have hydrogen. Okay, so it won't exhaust. Right. So we got a little far from our concept, but this is all about nuclear fusion and fission. Next, we were talking about this question,
Sir, you
which
didn't
is
upload the test results, sir.
I have uploaded on test results. Check
Sir,
check WhatsApp
thanks,
group.
sir. Okay, WhatsApp.
Yes. Fine. So this energy. Fine. The sun. Sun is a source of energy. Firefly is also a source of energy, and tube light is also a source of energy. Okay. Then what is the answer? Moon. Right? Okay. Let's move to next question. If light falls perpendicular on a plane, at what angle will it be reflected?
Sir,
What will
90
be the answer?
degrees. 90
0
degrees.
degrees, sir.
90 degree.
So shouldn't it be?
Yes, Karthik. You were saying something?
So it is 0 degrees, right?
Why 0 degree?
Because if light falls perpendicularly on a mirror, at what
Mhm.
angle will it be reflected?
Mhm.
According to the normal, right?
Mhm.
It- it-
According to normal. Yes,
yeah.
yes.
So it would be 0 degrees.
It will be zero. Correct.
But then there is no option.
Yes.
Why is 90 degrees the answer? I mean, I kept 90
No,
degrees.
no, no. 90 degree won't be
In
answer.
respect to the
Answer.
mirror, in respect
Un
to the mirror, it's 90 degrees. But respect to the
Mhm.
normal, it's 0 degrees.
In respect to normal, yes. What will be the angle? At what angle will it be reflected? So it will be a 0 degree angle. How? You are correct,
But sir,
Karthik.
here we are not talking with respect to the normal, right? So we're talking about the plane mirror.
Okay. Tell me one thing. What is normal?
Sir,
Normal.
90 degree.
But when we talk
Sir,
about reflection, we only talk about normal, so we don't take the plane.
sir, when the angle of incidence is equal to angle of reflection, and when the light falls on that angle, it will be reflected like in the same angle.
So tell me one thing. This is a mirror. Okay. So right, there was not any answer of 0 degree. So I forgot to put it. So we are like this is mirror and this is normal. Okay. So what is normal? Normal is any line which is
Perpendicular.
perpendicular to mirror. And if a light falls perpendicular to mirror, okay, let's say this light falls perpendicular to mirror. So what will be the angle of incidence?
Angle of incidence, it would be 90. 0 degrees, 0 degrees.
Zero. What is uh, what is the basic definition of angle of incidence? That it is an angle made
Ah,
with normal,
yeah.
right?
Okay, sir. Sir, but then here they didn't mention angle of incidence.
it mentioned angle of incidence.
Or should we automatically always refer to the angle of incidence when they talk about angle of reflection?
Yes. Can you repeat what you are saying?
I mean, like when they say at what angle will it be reflected, should we always consider about the angle of reflection, which is equal to
Yes.
the angle of incidence, not
Yes, yes, yes.
or not in relative to the mirror? Okay,
That's what what angle would be reflected. Okay, here in this question, it was asked about the reflected angle, not angle of reflection.
okay, sir.
Fine, fine. This question paper became much confusing. I prepared this question paper like in some hurry, so that's why this question, like, there is problem with the language. So don't worry. Are you clear with the concept that if I have asked that the what is angle of reflection, then what would be the answer?
0.
Angle of reflection would be 0.
0.
How? Angle of
Sir, with
incidence
this,
and yes, we
and
always measure angle of incidence and angle of reflection with respect to normal.
with
Okay,
respect to norm.
so if this angle, if this incident ray align with the direction of normal, then the angle of incidence becomes 0, and so as the angle of reflection. So I becomes 0 degree, R becomes 0 degree. But here we are asking that if light falls perpendicular on the plane, at what angle will it be reflected? So we are not talking about angle of reflection, whereas we are talking about at what angle it will be reflected. So earlier it told that the light is coming perpendicular to the mirror. So later also, if it is coming like this, so it will go like this. Okay, so in same direction it will go, and the angle of this reflected angle will also be 90 degree. Okay, any confusion?
No, sir. So the next one.
Others, any confusion?
No, sir.
Okay,
No, sir.
almost all of you have answered correct that it will be 90 degree. Next question, the angle between incident ray and reflected ray is 60 degree. What is the value of angle of incidence?
30 degrees.
30 degree. How?
So, sir, the distance between the incident ray and the normal is equal to the normal to the reflected ray. So if both are equal, so 60 degrees be divided by 2 is 30 degrees, because
Okay,
the normal splits the angle into half.
good. Ashwath is telling right that this we are given that this angle is
30.
60 degree.
Right.
This whole angle is 60 degree, and we need to find what is angle of incidence. And yes, we need to find angle of incidence. So
60 by
since
2, sir.
I equal to R, then we can say I equal to 60 by 2 or 30 degree. Fine.
Yes,
Any
sir.
confusion?
No, sir.
So the correct answer is 30 degree. Next, angle of incidence is equal to angle of reflection.
Always.
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 No, it won't be always, because until now we have seen then what is angle of reflection, but in some special conditions, angle of incidence cannot be equal to angle of reflection, and we will see
Sir,
how it works.
when it is not a plane mirror, sir, when it's a rough surface.
It is a rough surface. So we will talk about two types of
Sir,
reflection.
Sir, but
Yes.
in the rough surface also, when we draw a plane line, which is on that line, the point of incidence, the point of reflection, and the point of the normal, which is intersecting the plane lies. Even though
Okay.
even though on a rough surface, we can draw a line which is a plane.
Okay.
That
You are
at
saying
that point always the angle of incidence is equal to reflection, angle of reflection, because all these are only in respect to a plane surface.
okay. You are saying that all
Yeah,
the point of
because
incidence, the angle.
according to the definition, a point angle of incidence always lies on a plane. I mean, on a straight line.
We saw two laws of reflection. First was that angle of incidence is equal to angle of reflection. Other law was that all lie on
All
same plane.
on same plane.
Yeah,
So these two are different things.
yes, sir. But then
Okay.
when we draw, we have a plane, sir. I mean, how can we define angle of incidence? Can you define it? I mean, if we
Okay.
define, in the definition, we have the part that it always is in respect to the plane in a of a straight line segment. So when we are talking about angle of incidence on a rough surface, I mean, on a surface which is very rough and has irregularities on it, and when we talk about angle of incidence, we should also make the rough surface into a plane line. I mean, we have to draw a plane line. Is it so, sir?
In this case, tell me what if angle of incidence is equal to angle of reflection.
What, sir?
Is angle of incidence
No,
equal to
sir.
angle of reflection in this case?
No, sir. No,
Yes,
sir.
No.
No, sir.
Sir,
So here I is not equal to R. So these kind of situation is known as diffuse reflection. Diffused reflection. Okay, so until now we have seen that what is reflection. So what is reflection? Reflection is, are you guys there? What is reflection?
sir, the bouncing of light, bouncing
Bouncing
back of
back of
light from a surface. Bouncing back of light from a surface.
Act of light from a surface. And there are two categories of reflection. One is regular reflection and there is diffuse reflection. Do you know what is regular reflection?
Angle of incidence equal to angle of reflection.
Okay.
Angle of reflection is not, angle of incidence is not equal to angle of reflection and diffuse reflection.
So regular reflection we have studied until now. Okay, so regular reflection we have studied until now the regular reflection. So regular reflection happens at smooth surface.
Shiny surface.
Smooth surface. Okay, this difference between smooth and shiny. Shiny is regarding the look and smooth is the texture. Okay, so how that texture is. So any smooth surface reflection, any kind of reflection that takes place as at smooth surface is known as regular reflection. Example, tell me an example of this.
Reflection by a plane mirror.
By a plane mirror. Correct. So reflection by a plane mirror is smooth. That is an example of regular surface, a regular reflection. So what is plane mirror? We you daily see that the surface of plane mirror is very much smooth. That at if we go to the atomic part of that surface also, then we can see there is some regularity. Whereas in diffuse reflection, the surface is a rough surface. That is, if we go to the like atomic part atomic level of this surface, the particles can be arranged up or down situation. Okay, those, if we like see on atomic level, we can see that either they can be up, down, okay, some irregular surface. So due to which in this case the angle of incidence is not equal to angle of reflection.
Sir, in diffuse reflection, light is reflected into all directions.
What?
In diffuse reflection, light is reflected into all the directions.
Wait.
Sir,
Yes.
I've sent something in the chat. There is when it's such a actually this is correct in an irregular diffuse reflection. It can't happen, but when it is asked in exam, what option shall we keep? Because Byju's and Vedantu, they I just checked them right now. I checked everything. They are providing the angle of reflection is always equal to the angle of incidence. I gave it in the chart. They gave some explanation.
The surface on which light reflects is unequal. So you see that there is some condition given that if when it is examined at extremely small surface areas, okay, this is examined at extremely small surface areas. Okay, don't worry, we will see regarding this question that what should be the correct answer. Okay, but right now let's discuss about this rough surface and smooth surface. Okay, Karthik, I will again check that what should be the, like it should be under special condition or always, and then we will discuss this in next class. Is this fine?
Okay, sir, no problem.
Okay, so we were talking about diffuse reflection and yes, diffuse reflection and regular reflection. So in regular reflection, the angle of incidence is equal to angle of reflection. This is incident ray, this is reflected ray. So in this case, I is equal to R. Fine. Whereas in this case, if you make a normal, in this case, angle of incidence is not equal to angle of reflection. So can we say that the diffuse reflection does not follow laws of reflection? Yes. What are the laws of reflection? That angle of incidence should be equal to angle of reflection. All angle of incident ray, reflected ray, and the normal all should lie on same plane. Whereas in diffuse reflection, we can see that angle of incidence is not equal to angle of reflection. Okay, so does this diffuse reflection follow the laws of reflection?
No, sir.
No.
No,
So
sir.
diffuse reflection does not follow laws of reflection. So are you clear with this, that for diffuse reflection occurs in rough surface, whereas regular reflection occurs in smooth surface? like in the case of mirror, in the case of plane mirror. Okay, any doubt?
No, sir.
No.
No, sir.
Okay, regarding this question, I will check. Okay, because according to my understanding about this, that diffuse reflection and regular reflection, I have uh, given this answer as C, but okay, I will check it, that what it should be, like it should be always or under special condition. So it is asking that angle of incidence is angle equal to the angle of reflection. It should be always or sometimes or under some special conditions or never. So according to regular reflection and diffuse reflection, it should not be always equal to. Okay, but okay, I will check it. So we will discuss to this. Sixth, the image formed by a plane mirror. What would be the answer?
Virtual behind the mirror and of the same size as object.
Same size as the object. Okay,
Option B.
option B, correct. Anyone has any doubt?
No, sir.
No, sir.
This is plane mirror and this is surface, and a man is standing like this. So if it is a distance of like 10 centimeter, so image will also be at a distance of 10 centimeters from this mirror. If this is object, this will be image of what? Same distance from,
Sir,
yes.
sir, I have to leave now. Can I leave?
Okay, leave after 2 minutes. You can leave at 7:50. We will discuss one more question, then you can leave.
Okay, sir.
Okay, so this is property of plane mirror, that image will be of same distance from the mirror as that of object and same height as that of object. Fine. Next, tell me the laws of reflection.
So incident is the angle of incidence is equal
reflected ray.
angle of incidence is equal to angle of
Sir, incident ray,
reflection,
reflected
and incident
ray,
and normal all lie on the same
same
plane.
plane.
Okay, correct. One of you have written answer as incident ray equal to reflected ray. So we are
Sir,
not.
ray goes in infinite, sir. It
Yes.
goes continuously in one direction.
So we are not talking about ray, but I have asked about laws. Okay, so in laws, what will come? The angle of incidence is equal to angle of reflection, not the incident ray and reflected ray. Okay, so if like I have seen copies of you, so one of your friend have written that incident ray equal to reflected ray, but the law talks about angle, right? No need to say that it was you. I'm not blaming you to answer that question. Don't worry, Purujit. We are like figuring out how we can write correct answer. Okay. Don't worry.
Sir.
Fine. Next question. The distance between object and image found by a plane mirror appears to be 24 centimeter. What is the distance between the mirror and the object?
12 centimeters.
12 centimeters.
12. Okay. How?
Sir, in image and object, the distance between object and image, object and plane mirror, plane mirror, and the mirror to the virtual image is of same length, sir. So if the distance from the object to the image is 24 centimeters, we can divide it by 2. It will become 12 centimeters.
12 centimeters. Correct. So we are given that the distance between what?
The object and the image is
and
24
image.
centimeters.
Object and image is 24 centimeters, but we need to know the distance between the mirror and the object. So since both are from same distance from the mirror, so we can divide this by 2. So this will come as 12 centimeter.
Sir, can I leave?
Yes, you can. Okay, we will discuss these questions in next class. And we will also discuss this one question next class. Fine. And we will again discuss this question, which was angle of incidence. Okay, we will repeat this question so that we are clear. Okay, no, not this question, but this perpendicular question. Okay, so again see this question, what is the language and how, what the answer what answer came, and I will give one more question regarding to it, so you should be able to solve. Okay, so revise all of these concept we have learned until now, and we will discuss further in next class.
Sir,
Yes.
this is the last doubt. They're told
Yes.
that the first law of reflection, where the angle of incidence is equal to the angle of reflection,
Mhm.
in that they have said at an extremely small scale, any
Mhm.
angle of incidence is equal to angle of reflection. For example, if
Okay.
you break down an irregularity into a plane, I mean, you can break down an irregularity into plane, right? You can draw
Mhm.
a line in which the irregularity is pushing the light away, reflecting. So you can draw a line
Okay.
there and draw perpendicular, and then the perpendicular exactly bisects the angle. There again, the angle of incidence is again equal to the angle of reflection.
Nice.
Is it so?
Okay. Wait. Let's say example of a mountain. So as a whole, this mountain has irregular surface, right?
Yes, sir.
Tell.
Yes, sir.
Okay.
Sir,
So
can I leave? I have another. After
fine,
my.
fine, fine, fine. You can leave. If anyone is interested in this question, you can stay, and others can leave. And we will discuss the question paper in next class. Okay, remaining question paper. Fine.
Bye, sir.
So, okay. Bye. Good night. So we are talking about this.
Bye, sir.
That
Good night.
this. Good night. The surface. This surface of mountain is not regular, or we can say smooth.
Yes.
Is it correct?
Yes, sir.
Yes. So this surface is not smooth. So it has some irregularities. And if I zoom to this surface, let's say, and I zoom inside, and there are some stones. I'm taking a very small stone, okay? Okay. Let's say there are some stones of this shape. So can you say that the surface of this stone is irregular?
No, sir, it isn't.
It
It
isn't.
is, it is plain.
It is
So
plain,
when,
or we can say it is smooth, right?
yes, sir.
Okay. So similar is the case of those smooth and hard surface. At as a whole, as a if we say at a large scale, we can say that it is a rough surface. But if we zoom, and we go to the very small scale, so at very small scale, that the small part, okay, we are talking about small part of this mountain, small part of this mountain. So at very small part, that small part will appear as a
Okay.
plane, or we can say smooth.
Okay,
It
sir.
will appear as regular.
Okay, sir. Got it.
Okay.
Yeah.
So
Sir,
like, yes.
yes, sir. Tell me.
No, no, ask what you were asking.
No, I was not asking. After you say everything, I'll say.
Okay. So in higher classes, you will get to know that there are what I say, you do project. Like my project was on Raman scattering. So in Raman scattering, what we have a material, let's say a square film of silicon. Okay, we break this silicon at very small part. Let's say very small part. Okay, so there are some materials like some liquid that HF or what I say chemicals. So there are some chemicals that break this silicon film into very small part. That is, film is of the size of 9 nanometer, 9 nanometer or 10 nanometer. So can you see how much small it is? That 9 into 10 to the power 9 meter. Okay, it is this much small. So with the help of these chemicals, we break it into these small parts. So if I run an experiment on this whole film, that I can see there are some rough surface. Okay, if I run some experiment, like let's say experiment of this deflection. So this we might not be able to see the angle of incidence equal to angle of reflection at this surface because it is rough. As a big bulk, as a bulk material, okay, as a bulk material, it is rough. But when I have broken down this material into very small scale, which is 10 into 10 power 9 minus 9 meter, then we observe that this surface is perfectly smooth. Okay, perfectly smooth, right?
Yes.
It is very smooth that if we perform that experiment on this part, we will be able to see that angle of incidence is equal to angle of reflection. But now the question arises that how this bulk part become rough. So this smooth part, what
They
this
make
will do?
irregularities.
Yes, the arrangement of these small smooth part will lead to irregularity on as a whole, as a bulk.
Okay, sir.
Okay, so at a very small scale, it will appear as smooth, but as a bulk scale, it will appear as rough. Fine.
Okay. It's
Now
because
ask
the
me.
arrangement of these particles is not so perfect.
Yes, arrangement of these particles is not so perfect. Like if you see atom,
Atom.
atom itself is a regular is a arranged like a symmetric part.
Okay.
Okay,
So it's 100% smooth, an atom. Is it?
atom, yes, atom is 100% smooth because atom, the smallest scale at which we can reach is after atom, it is electron, proton or neutron. Okay, the smallest part of a molecule, what it is atom, right?
Yes, sir.
Okay, and smallest particles are electron, smallest particles.
Okay.
So atom is the building block of any material. So atom is smooth. I have done this experiment that I have broken down into small film. So is this a small film equivalent to atom?
It's kind of, sir.
No, it is not, because I have broken down it at the scale of 9 into 10 power 9 meter,
Yeah.
whereas atom goes to 10 to the power minus 15 or 10 to the power minus 20. It is this much small. Okay, the radius of hydrogen atom is picofarad, something 0.5.
Sir,
Yes,
can I leave, sir, now?
yes, you can do it.
Okay, thank you, sir. Bye, sir.
Bye bye. Wait, hydrogen atom 53 picometer. 53 picometer. Okay, picometer is 10 to the power minus 12. Picometer is stands for 10 power minus 12. Fine. So if I round off this, then it will be 0.5 into 10 power minus 9 meter. 9 minus 10. Or if I more round off, then will it 0.05 into 10 power minus 9 meter. So means I have to break down into 100 parts. If I break this small material into 100 parts, then I will be able to reach to the atomic level. Okay, so atoms are this much small. So with the present technologies, we can break any material to small, but not at an atomic level. Okay,
Okay, sir.
this material is still big. Fine. Any more doubts, Karthik?
No, sir.
Okay, great. So you see about that thing, like that question on internet and in your NCRT. If you found a satisfactory answer, then you tell me in next class. Okay. Okay, great. Fine,
Bye.
then let's meet in next class.
Bye,
Bye
sir.
bye.
Thank you for the
Bye
class.
bye. Good night.